Hey, I would like to take a look at this sheet again because when we did it before, when we did our graphing, again, this is the graphing exponential functions using transformations. What we did was, again, as I mentioned in class, kind of a lot of hand waving. Just shift it down 2, shift it to the right 1, stretch it by 3. And I know some of you were not thrilled with that method. And so the method that we used in class to graph the logarithms, I want to show you how to do the same thing with these. So I'm going to start with problem 7, and then I'm going to move on to problem 9, and then I'm going to ask you to do some of these on your own. All right, actually probably just problem 10 on your own, because I just want to make sure that you're able to do it, because again, this will be a good strategy for the test on this section. So again, as we mentioned in class when we were doing the log ones, the first thing we need to do is say what is the parent. And again, when we do that, we strip away all these changes, the shifts up and down, the shifts left and right, and we say that the parent is just y, or f of x, equals 1/2 to the x. All right, there's nothing fancy going on here. That's just the basic plain function. All right, and then what we do, and again, we're going to run into a little bit of problem with space here, but let's see if we can do it. The first thing we're going to do is we're going to plot or say what the ordered pairs would be for several of the points in the parent function. So I'm going to go with -2, -1, 0, 1, and 2. We may need to change that a little bit after we start graphing it and realize that maybe the points that we picked won't even be on the graph, but let's start with those. Whoops, sorry. I'm so used to doing it for logarithms. Let's try that again. -2, -1, 0, 1, 2. So I'm going to plug in each of these points into my parent function and see what we get. So I plug in -2 here. Again, the negative flips it and the 2 squares it. So we're going to get 4. And then I plug in -1, it just flips it. I plug in 0 and I get 1. I plug in 1, I get 1/2. I plug in 2 and I get 1/4. Now, there are 2 transformations that are happening. One is a left-right shift because of this +3. It's actually going left 3. But again, it affects the x value, so I'm going to put it right next to the x over here. And I'm going to say because we're going left, we need to subtract 3 from the x values that we have here. And then the second transformation is this shift down 4. And again, because that's an up-down, that affects the y, so I'm going to put it right next to the y, and I'm going to say I need to go down 4, subtract 4. So now in these columns right here, I'm going to do exactly what it says to do here. So I'm going to take the x value, and I'm going to subtract 3. So -2 minus 3 is going to give me -5. -1 minus 3 is going to give me -4. 0 minus 3 is going to give me -3. 1 minus 3 is going to give me -2. And 2 minus 3 is going to give me -1. And then I'm going to do the same thing in this column, but with the y value. So 4 minus 4 is 0. 2 minus 4 is -2. 1 minus 4 is -3. 1/2 minus 4 is going to give me -3.5. And 1/4 minus 4 is going to give me -3 3/4. Now when I go to plot, I'm going to plot the outermost columns right here. This is going to be what we plot as the x value, and this is what we plot as the y value. So when we do that, and I make my, I put in my axes, I need to go only negatives for my x's. So I can put my y-axis, like, I don't know, let's say over here. All right, I don't need any positive, x's. And then for my y-axis, again, they're almost all negative, so I can put my y-axis up here. And I just like to skip count by halves so that I get it a little bit spaced out. So that's -1, -2, -3, -4, -5, -6, -7. And then same thing here. 1, 2, 3, 4, 5, 6, 7. So 3. No, that's 2. Okay. All right, so now we're going to plot. So at -5, it's 0. At -4, it's -2. So I'm down 1, 2 right here. At -3, it's -3. At -2, it's -3.5. So at -2, it's -3.5 right here. And at -1, it's -3 3/4. So right about here. Right? I know that it's exponential decay because this fraction is less than 1. So I'm going to curve it down like this. I also have to be careful because I know I need to put in a horizontal asymptote for this type problem. And again, that horizontal asymptote comes from right here. So it's going to go something like this. All right, so don't go crazy and try and cross that. Again, it's just going to hug that as it gets closer, as the numbers get farther and farther into the positive side. All right. Again, what we did before was we plotted that new origin, and our new origin would be at -3, -4. So -3, -4. If you were talking about that old method we just did things relative to that new origin. So again, this would be another way to do it where we don't have to use that the new origin. We can just find out what the parent looks like and then do these transformations and get those new points. All right, let's take a look at problem number 9 because this has one of each type of transformation. It has a shift to the right, it has a shift down, and it has a stretch of 3. So this is new. And so we didn't get to see that when we did the log ones. I want to make sure that you see that here. Again, this is so tight in here. I'm so sorry. Again, the first question would be, what is the parent? And the parent is whatever the function is with all those extras stripped away. So this would end up being y equals 1/2 to the x. All right, so just as before, I'm going to plot or find the ordered pairs for those that function. So again, I'm going to choose -2, -1, 0, 1, 2. I already know that the values are 4, 2, 1, 1/2, 1/4. And now comes the part where I put in the other things. Now, since there are 3, the question is, well, I know where this one goes. It's grouped with the x, so it goes on the side of x. We already did ones like that. That moves it up and down, so that's with the y. But what about this? Right? Where is that going to go? Is it going to go with the x or the y? The short answer is if it's not up with the x, it doesn't go with the x. But why does it go with the y? And the reason is, again, because what it's doing is it's making the graph grow taller, faster. Or if this was a fraction, maybe it would make it grow short, like more slowly. So it's affecting the up and down direction, which is the y. All right, so that's why we're going to group that on the side of the y. The second question, though, is which one of these should come first, or does it not matter? Right, and the answer is order of operations tells us which to do first. Right, so here the 3 is being multiplied by this, and the 2 is being subtracted from it. And in order of operations, we always do multiplication first and then subtraction. So we're going to do this times 3 first. Again, I'm going to do times 3 because it's 3 times whatever I got here. And then, this is going to be so tight. In fact, I think I might just shift it over a tiny bit. I'm sorry for this pause here. Go get yourself a drink or something while I'm scooching this over. Let's move it so that this is going to be the x column. So then we've got x, we've got y, we've got the first y column, and then we've got the second y column. I think that's going to work a little bit better. So -2, -1, 0, 1, 2. This is 4, 2, 1, 1/2, 4. Okay, so the times 3 is going to go in this first column. It's not x3, it's times 3. And then this -2 is going to go over here. Again, that's because of order of operations. Multiplication comes before subtraction. And then I'm going to do +1 because this is a shift of 1 to the right. So now I'm going to add a 1 to all of these. So this -2 + 1 is -1. -1 + 1 is 0. 0 + 1 is 1. 1 + 1 is 2. 2 + 1 is 3. Now here this is saying multiply each of these y values by 3. So this is going to become 12. This is going to become 6. This is going to become 3. This is going to become 3 halves. And this is going to become, oh, sorry, this should be 1/4. This is going to become 3/4. And now what we do is we subtract 2 from this column. All right, so after we do this, then we do this, the subtract 2 to the column that we just formed. So this one is now dead to us. All right, we no longer need this. We're working from here. So 12 minus 2 is 10. 6 minus 2 is 4. 3 minus 2 is 1. 3 halves minus 2 is negative 1/2. And 3/4 minus 2 is negative 1 1/4. So again, now we graph the outermost columns. All right, so our x values are going to be negative 1, 0, 1, 2, 3, and our y values are going to be 10, 4, 1, negative 1/2, negative 1 1/4. Since our asymptote, our horizontal asymptote is going to be at negative 2, I want this to be my last value, negative 2, down here. I might not be able to graph all of these, so we shall see, but this I'm going to make as negative 2. I need mostly positive, so I think I'll put the y-axis right here. And then this is negative 1, and this is 0. We might have to kind of fudge it for the that first one, but we'll see. There's negative 1, 1, 2, 3, 4, 5, 6, 7, and then this is negative 1, 1, 2, 3, 4, 5, 6, 7. Let's put that up here. Yeah, there's no way we're going to fit that 10 on here. So let's just cross that out. If you decide that you want to count by ones, like some of you like to, then you'll be able to fit it on there. I just don't like to do that, so I'd rather just cross that point out. All right, so this tells me at 0, it should be 4. This tells me at 1, it should be 1. This tells me at 2, it should be negative 1/2. This tells me at 3, it should be negative 1 1/4. So right about there. We could probably actually do a positive 3 and see what we would get. This would shift it over to 4. Our y value, so this would be 1/8 times 3 would be 3/8. And then minus 2 would be negative 1 5/8, so just under negative 1 1/2, so maybe right here. All right, so then our graph is going to look something like this. Sorry, it's hard to graph when I can't see through my hand. Oh my goodness. Okay, so it's going to look something like that. And that should be what you got when you did it the first time. All right, so we didn't talk about this in the problem up there, but domain, all real numbers, range, it's always wherever that is going down or up to, that's going to be one end, and then it's either going to be above that or below that, depending on whether we flipped it over or kept it upright. So here it's negative 2 to positive infinity, and our horizontal asymptote, HA, instead of VA, is going to be at y equals negative 2. All right, so I would really like you to try doing that method with problem 10. All right, you'll have a little bit more room here, which is good. And again, this 2 is going to stretch it, but the negative is going to flip it. So instead of looking like this as exponential decay, it's going to flip it upside down and look something like this. All right, so I want you to graph it again using this method, and then I want you to check the answer key that I've attached just to make sure that your picture looks good compared to it. Now, things that could make you think your graph is wrong or your picture is wrong is if we used a different scale. So, you know, again, I tend to skip count by halves. I don't remember what I did on the answer key on that, but that might be different if you chose to count by ones. Same thing, your scale here might be different than mine. So take that in mind. If you would like me to look at your graph because you're not sure if it's correct, please just take a picture of it and send it to me and I'll let you know. Okay, good luck.